So we have 2 hours with you, and I'm looking forward to it. I always say, and I said it in Twitter yesterday, that when they ask me, where are you from? I'm from Bilbao. I'm a fan of Athletic de Bilbao from 88, but I was born here in Santander. My family are from Cueto. We are from Cabo Mayor. We are from Santander. So for me, being here, it's like being home. Maybe if you don't know me, this is something that you always repeat everywhere you go. But I'm very happy and excited to be in Santander because it's the first time I can give a talk about a subject that I just love, blockchain. And this is not just looking for your applause, but it's a pride. So we have 2 hours. It's 2 hours of excitement. Today we'll speak about blockchain and Bitcoin. It's 9,400. Yesterday it was 11,500. It just in a couple of hours this is changing so much. I don't know how many of you have Bitcoins. Doesn't matter, no problem. We can't see you in the cameras. We can't see you in the room. At least 2 people. Yes, 6 people for the one dynamics and 2 other to steal money. So you'll be participating. So we're trying to explain several concepts about how the blockchain technology works. We'll see some applications that are interesting for us in the cybersecurity unit in Telefonica. That we feel that these apps are attractive for developing malware and for evil, but this technology offers other functionalities that are good, and we need to know them. So we have to have them in mind, especially when we need to make analysis. So the blockchain and Schrödinger's cat. This is a metaphor. Why? We'll see that. Yes, we'd like to explain what is blockchain, why these systems that are decentralized did appear with this mental exercise in 1935, was created by Erwin Schrödinger. In this exercise, there was a cat inside a bunker with powder. So for an external agent looking at the bunker from outside, there's the same probability that this powder blasts and kills the cat, and the same probability that the cat can survive. But until you enter into the bunker and you see what happened to the cat, that you realize what happens. So the cat is dead, or it has survived because you introduced powder. So it's about curiosity that people have. What's happening inside? Here it's inside a bunker, but we deal with security and we have all the tools to enter the bunkers. Technology, and blockchain in particular, was born because of society. Thousands of years ago, we delegated responsibilities on governments, corporations, companies, and we devolved our responsibility. And in a way, we have decentralized that responsibility because we don't trust them fully. So we have a free software coming out from that. What we want to underline is that these technologies and free software, we are believers in free software. This tries to answer this opacity. These big companies, we don't really know how they operate with our data and our information. And free software uses code. Charles Stallman and all the people working in free software, you know, the 4 freedoms: to read code, study the code, modify the code, editing it, and distributing the code. And what are the 4 freedoms? I just can't remember now. So 4 freedoms are in software and applications. What happens when this is included in a connected system? At the beginning of the 90s, If you had internet connection, you were lucky, but today almost all of us are connected. So the solution to avoid this type of decentralization problems or opaqueness of big companies is something that we can solve with blockchain. Let's see how blockchain works. Imagine that Alice wants to send bitcoins to Bob. She'll make a transaction and she'll sign it with her private key. She only knows her key. Sometimes she doesn't know the key. So sometimes we have to be careful with keys. So the information of this transaction signed by her is notified to the rest of network hubs. And after the validation, one of the hubs will be add the block to the new block to the blockchain. And blocks are not added in a specific way. Blocks are added one after the other. It was started with bitcoins. 9 of January. Then the 8th of January 2009. That's when it started. This Bitcoin proposal started in 2008. It's a figure, but we don't know if it's a figure or a group of people or a collective. I don't know. It's a group. So this started to be implemented in 2009. And chain in the blocks. All the blocks are chained. That's why it's called blockchain. So if you change a Bitcoin, the sequence is changed, and persistency will disappear. So information is replicated in all the hubs of the network, and Bob can use the Bitcoins that he received and which were transferred by Alice. What does this imply? All the hubs, the full hubs in the Bitcoin network have the copy of the accounting log with all the transactions that are being generated throughout the history of this blockchain. This implies that, in fact, well, we can say it's inefficient because all of them have the exact copy. Could be 150 giga. If we want to buy a good piece of equipment, if we have to put one SSD with 150 giga, it's too much. It's too much. It's getting more and more expensive. If we only want bitcoins, if we want Bitcoin, gold, cash, etc., our SSD will need to be teras and teras of capacity. So we add a block in the blockchain, and for this we need to do proof of work. POW. This means that you have to solve a mathematical test. If you are faster than others, you have more probabilities to add your block in the blockchain. This mathematical problem, in fact, if we were all part of the Bitcoin chain, we don't really know who's the next network hub, who's the next, who's going to add a new block. So there's nobody that can say that I'm not going to add this block. You don't know who's going to do it after you. It's random with an algorithm, a random algorithm that we will introduce, and maybe the next block is not entering, but the next after the next, maybe it's someone who doesn't know that his or her block are going to be added. It's not about this access. You give it away because there are incentives. The goal is to represent what this blockchain is all about. Let's do an exercise. Let's play a game. We need volunteers, 6 volunteers for this exercise. And there's an award. There's a prize. You're going to have to win a prize. Please, volunteers, come up here. These 6 people have to play together and pool into groups for this computational capacity. The idea is to mine. So pool 2 is made of 3 people. Pool 1, 2 people. And there is an isolated hub. 15 euros. Come up here. There's a prize. There's an award. Anybody? We need more people. Come up here. We need 6 people. Okay. So, we're going to team in the following way. A group of 3 people, that's pool 2. So we'll look for a solution if you know other people in the team. Another group of 2 people, another person who will be alone, the isolated hub. Let's imagine that we all have a computational capacity that is standard. It's more or less the same. So we are all clever. The team with more possibilities to add the next block is the one who is composed of 3 people, because you're 3. We have the same computational capacity, but we are 3. You have more possibilities to find the solution to this mathematical problem. Sometimes we've played this game and people didn't understand. So, pool 2 is 3 people collaborating. 2 others will be the pool 1, Daniel and Christian. Second pool, the mining pool, not 1. And you are the isolated hub. You're alone. You have less probabilities to win, but sometimes the isolated hub wins. Well, maybe you can win also, even though you're only 2 or just 1. We have 6 hubs in our networks. And we have to show that we have money. We have money. So we're now looking at the money for this address, starting with 1x7. All the Bitcoin addresses starts with the same letters. It starts with 1 or 3, the Bitcoin addresses in the mainnet. And testnet starts with M or N. So when we see this chain, this long, maybe it's a Bitcoin address. In this case, how much money? 0.0716. Very little money. It's about 15 euros. 15 euros. That's the money that's in there. You can use the Going Market Cap. It's quite a well-known website where you can follow the evolution of prices. How much a Bitcoin is now. $9,500. So, Ethereum, it's evolving, it's oscillating. This is real time. You see how much it costs and the exchange rates. At the beginning, it was just €1. 1 Bitcoin, €1. And we're here telling you stories, but we could have been rich. The mathematical exercise, we have a ready, and we'll see the mathematical operation. Very simple mathematical exercise. If you discover the answer, raise your hand and you say it, okay? Now, we have the blockchain until now, and suddenly we have to decide who adds the next block. Problem, an operation. Look for a number that can be divided by 7 and by 5, and which is greater than 1,000 and lower than 2,000. So please raise your hand. Why 1,400? Well, yeah, that's correct. This number can be divided by 7 and by 5. This team has solved the problem first, so you have the privilege, plus the Bitcoins that you're going to win, you have the privilege to add the next block to the blockchain with the 3 actions that will be generated. The next block, well, once this one has been generated, there's another mathematical problem, and then we will see who wins and who puts the next block. Next block, there's another mathematical problem to solve. And the problem, in fact, is not multiplying 7 by 5 and see if it's greater than 1,000 or lower than 2,000. It's to identify a hash that starts with 20 zeros. And the hashes have to start with the 21st digits, and they have to be zeros. And as the computational capacity of the network increases, 600 or 60 or 6,000, you will have more possibilities to identify in the network a hash that starts with I don't know how many zeros. The hash generation, we don't know it until it's generated. So it is distributed. So congratulations, pool 2. Yes, pool 2. You're going to win Bitcoins. Do you have Bitcoin address? Some of you have a Bitcoin address? Well, we'll explain how it works. How? We're going to make this Bitcoin transfer. Let's explain the system and how it works and how we can transfer you the money. So we have a winner. Don't leave, because I have to give you the prize. You have to wait until the end of the talk. So how are we going to store this private key or this address that we need to send to our colleague? It's called e-wallets. It's a software or a hardware that saves these addresses or private keys. These private keys or passwords indicate that it's our. You have to save the passwords, private key, public key. If we lose the private key, we can't really show that Bitcoins are ours because they are in our address, but we have to demonstrate that. What happens? Sometimes, because we're not very good at that, because you don't give it the importance of it deserves, you get to get your first Bitcoins. You go to add pages and you click on that and you have captchas and you get thousands of Bitcoins. Or sorry, it's milli Bitcoin. Today is $1 or $10. You get milli Bitcoins. You have the Firefox, you put it in your virtual machine and you start winning Bitcoins. So you started to mine and mine and mine. And you have cents of Bitcoins, and I protected them in a wallet that I had in my equipment, in my PC, with a password that was very good, so good that I just forgot about it. And what happens? I don't know the password. If I don't know the key or the password I use to protect the private key of my Bitcoins, I just can't get the money out. If you go to a bank, well, you need a password to get the money. I can't use my money. 39 cents were to $3. You can't recover that because you had generated it from your client in your computer. And my e-wallets were encrypted, and some other software do that for you. But the wallet, what about the wallet? I can't really look for my password. So my e-wallet is base 64. This is a challenge that we used in Router in 2015. So we put it in base 64. This is the wallet. You can paste bin. You can see it in paste bin. You can see it in the YouTube image, in the video. So you download this base 64. It's a CTF, which is a real CTF. It's an e-wallet with encrypted keys. And today, if you can decrypt it, you can get this 39 cents of Bitcoin. And if you can do it, well, you can buy us some beers if you decrypt it. You uncrypt. Let's imagine this is 100,000. It's $45,000. It's a lot of money if you can decipher it. It's a problem, and we need to solve this problem that I forgot my password. So I cannot recover this because I can't decode, because I protected my private keys. And that's a problem. And I'm not the only one. What are the addresses that we use? Well, we have the random addresses in a random way. I'll show it to you now. Bitaddress.org. This is a free software project. This is a repository. It takes the positions of, you see the green dots? These are like random seeds. So I don't know if there's a technology that takes all the points. These are seeds to generate this. A Bitcoin address that starts with 17, etc. And a private key that's been generated from these green points, the zero random points. But you don't need to have an address. You can have many addresses. Bit address, you can generate more. And another one, it starts with one EME, one Q, K1. It's a rapid way of generating addresses. Another type, if I lose this, if Yaiza loses this, she cannot control that. It's what happened to me. So take this into account. This is public. The address is public. I give it to the people I want to be paid from, and this is the private part, the private key. Another type of e-wallets, the Bring wallets. Here, we put a keyword, CyberCamp, 2017 Santander. This is going to generate an address and a private key. En Route 2 years ago, we did this exercise to take a lot of dictionaries and generate a lot of addresses, the greater number of addresses. So people had taken this decision to do this type, to have this type of wallets, but if you know the word, you can access to these private keys and steal the money. This is a bad practice. This is bad practice. Instead of using a zero random seed, we have been using a word, and that's full of problems. I have the advantage that I can go anywhere, and without being a Bitcoin client, I am generating this address on the spot. But we did it in Unrooted and analyzed 4 million words. I can look for the presentation, password, hello, very well-known words in dictionaries, and the number of transferred Bitcoins to wallets that were generated in this way was around 20 or 19 Bitcoins multiplied by 10,000. It's not bad, $3,000 at a time. It's not usual. Some of them existed at the time. Then we have the multi-signature wallets. These wallets have 3 addresses. So when you configure the addresses, you can choose how many addresses are necessary or which address is necessary to move the money, to transfer the money. And you unblock the private key that is going to move the money out of the wallet. This wallet starts with the number 3. The normal addresses start with 1 in Bitcoin. And for wallets generated in this way, it's not the original standard, they start with the number 3. Maybe what is the type of problem that this tries to solve, this type of wallets? We can generate a wallet with 20 public addresses. If I have 20 addresses that participate in this wallet and I say, no, I need at least 15 of those to move the money, to transfer the money. What's the problem that this solves? We can't hear what they say in the room. Yes, we need you to say it in the microphone. In a company where capital is shared between different people, what happens is it's just in one address with one private key. I have the money of my company here in this Bitcoin address with one private key. And we have, the two of us, we have the copy of the private key. And then I go away, but I trust her. I go during the weekend, and during the weekend she transfers the capital of our company, because she's got the private key. She transfers it into her account, and she says that it's been stolen. What do I do? I've been cheated. So to solve this problem, yes, you can't go back. You can't go back. You've done a transaction and you can't go back. You can't undo it. There's no backup unless Yaiza decided to give me the money back. So with this solution, if we have two addresses, we can generate one multi-signature address. So requiring that to transfer the money, we have to sign together. We have our own private key, and we need to sign. Both of us need to sign for this transfer. This is typical. As we can see here, this is not new, about stealing wallets. It started at the beginning of 2015. There was malware that used to steal these small files where the private keys are stored in your computer. These files are not protected with a private key, and it's left like this. Any malicious program or malware can find that for you, and they can steal it from you. If you haven't protected it with a password, or if they're protected with a bad or a weak password. And people are now using this type of systems with this type of currencies, and there's a lot of phishing and other types of problems. 2 years, it was in 2015. It was quite rare. It was infrequent. We had Zeus, it's the banking malware, and there were instead of banks, it was domains, and there was malware directed to that type of stealing. It was attacking exchange platforms and markets, etc. So they were affecting platforms. And the wallet stealing malware is there, out there. You can sometimes install it by defect, and you can't see it, and it will steal your keys. And there's a small file, JSON, with the data related to your wallet. If we don't protect it efficiently, if I was doing malware, well, it's easy to steal. There's a risk. And then we have another problem. There are more and more projects with currencies, with market cameras, 1,000 or more projects. And one of them is Bitcoin Gold. This is on the 26th of November. We are on the 30th of November today. It was last Sunday. It was a note that was published. The source code that were published, which is a Bitcoin Gold. It's a new cryptocurrency related to Bitcoin. Well, the hash of the file that was being distributed with the official hash. But this file that was distributed for 14 hours, no, it was 4.5 days. It's written here. Maybe there was a malware inside that was stealing or was looking for this type of files. This problem is now affecting cryptocurrencies. And now we spoke about mining incentives. You were contributing with your computational capacity because you wanted to win the game, because there were going to be new currencies to be generated in Bitcoin. And when we make a transfer, Bitcoin transfer, we don't put a commission on top of it, but we want to include a commission so that we can attract those miners so that they can add their transactions, or they prefer my transactions, so instead of others. So the creation of new currencies, we can see it in blocks.info. What are the incentives for miners? With another transaction. Let's see the concepts, the theoretical concepts. We take a block, the last one, this starting with 4. There are hundreds of thousands of blocks, Bitcoin blocks, and this block was, I don't know if you remember, it was a transaction set, or a set of transactions that were being added by a miner and being added to the previous one. Here is the result, up here, yes. And in this block, well, the reward, what is the reward for this block? 12.5 Bitcoins. Let's see it. Every time we generate or we add a new block, the miners are giving you rewards because you are increasing the computational capacity because a lot of gigas are dedicated to that. So the reward, what is, they get paid with newly generated currencies. And then each of those transactions, which are quite big, each of those transactions, we can click on one, not that one, this one. This is a transaction where there is an address, UQHJ, that transfers money to 10 different direct addresses. Each of these transactions here indicates an amount of a commission that I want to pay the miner. These commissions were just cents now. It's $7 or $8 on average. This is the commission. Some platforms have like tracking of these commissions. So when did the system start? Well, the first operation that was registered in the blockchain was block 1, corresponding to block 1, and it was registered on the 9th of January 2009. There are no entries, there's no address that is sending money to another address. These 50 Bitcoins are generated at the beginning when there was a block added to the blockchain. Miners received 50 Bitcoins, that was the award. How many dollars? A lot. That's a lot. Then we see another operation, another transaction that is, corresponds to the currency generation. That's another block. But then we see the normal transaction. It's the one here, 12 CB, etc., with 50 Bitcoins. And then this money is divided in 10 Bitcoins plus 40 Bitcoins. That's 50 Bitcoins. So there are two different transfers to two addresses. So this is the first transaction. It was money transfer, a Bitcoin transfer from one address, from one Bitcoin address to another Bitcoin address. Until then, I don't remember the number of blocks, but it was mined on the 12th of January, 3 days later. We can look for the number. Until then, all the blocks had transactions from Bitcoin to real money. So the money had to be entered into the system. It's not exactly how we did in the exercise, but they started to distribute Bitcoins. This is a little bit about what we said earlier. You've seen the first minting of the money was for 50 Bitcoins. That's what the miners got. And every 4 years, it's when there's a new halving. That is, mining received half the money that they received previously for minting the money. This is November 2012. It's almost every 4 years. And really, it's every 210,000 blocks that are added. The reward is divided by half. So what we're seeing is that in the end, miners aren't going to find it profitable to mine in this system because of the minting. The commissions they receive is going to be reduced by half every 4 years. The estimation in this graph is to 2140. And that's where we'll reach the limit, 2136. In blockchain info, you can have a look here at block 210,000. 210,000, that's block 210,000. It's getting a bit stuck. This is block 210,000. Here you can see the block reward is just 25 bitcoins. If we look for 209,999, there, the reward is 50. It's difficult that you're giving the same computational capacity, but just because you did it 10 minutes later, you only get half the reward. And that's a block from November. I think we're now not in 25 bitcoins. We've gone down. It's now 12.5 bitcoins. Since about July 2016. So what's going to be the other operation which perhaps compensates a minus? Well, the idea of commissions. To carry out a transaction, they're going to include a fee. If I was a miner and I wanted the commissions of all the transactions that exist, I'd probably want to get there first so I can get more money. And the example that we gave a couple of years ago, we had of a wallet which had an address with a keyword. I can't remember what the keyword was now, but there were people within this system who were monitoring these addresses with these keywords. Maybe the keyword is password, for example, and we saw that in certain seconds of times there were 3 addresses asking for the money that we had. That is, 3 different people were signing transactions to get the money. That could happen. 3 different people are doing it at the same time. So in this process, when you have to be quick as possible, what did one of the addresses do? They said, okay, I'll increase the commission so that miners give priority to their transaction, as opposed to the others. What we wanted to do is to sort of put out a bait there, a bait of money to see how many people were out there. And it's a good example because there were people out there monitoring lots of these kinds of accounts. So approximate, we've got an account here. How much are miners receiving at the moment for minting new coins? 12.5 bitcoins for minting. And a 15% commission at the moment is around 2 bitcoins. So it's 2 bitcoins, depending upon the time. If now we went to the next halving, that is the next time the amount for minting money is halved, then it would be the reverse. So miners would then receive 6.25 bitcoins. Let's leave the commission as it was. Let's just assume that the commissions are what they were. But what does that mean? It means as halvings continue, the commissions side of things is going to be increasingly important. So the idea is that miners have sufficient incentive to increase their computing ability. And as for commissions, this is a typical supply and demand graph. On the x-axis, we've got the space for each block. We said that in each block you can include a certain number of transactions, and on axis y, the commissions that you have to pay. It's important what the author is saying, because x represents the space that you can include
of transactions every 10 minutes. The mathematical problem is, on average, solved by each node in the network, each hub in the network, every 10 minutes. If it was a lot quickly, you'd add 24 zeros. It isn't a normal graph. Here we have something that limits us, which is the space in each block. Today, a Bitcoin has 1 mega of space. And at the moment, this system is becoming increasingly important. It may well be that now, initially in each block there was 2 transactions, but now, as this system is becoming increasingly popular, more transactions are being included in the block space. That is, the block is being filled up, so the balance point is going up, and the price of the commissions to pay is going up. As the block fills up, the commission price goes up. So instead of getting a traditional supply and demand curve, as we've got a quantity that we can't go beyond, then the increase in price is going to be a lot greater. In 2012, people thought, oh, Bitcoin's great because you can save commission. But now commissions are around $8. For example, we've tried it. You can sometimes put 10 euros and you get 3 euros in commissions. But I think a year or so ago, in a hackathon that we organized, we presented this new product. And when we organized the demo, by the way, we've been working 24 hours all night preparing the product for the demo. We put the commissions high so that people could see that what we'd done worked. But in the end, that was how it looked. And some people didn't understand this project. And the blockchain didn't show the transaction. We thought it didn't work. We were a bit too greedy with the commissions. No miner was interested in, at the demo time, to add our transaction. We're just being too clever for our own good. If we apply this to real life, imagine a system in which Bitcoin's used. If I take 15 minutes for my transaction to get to be priority and to be confirmed, they're going to Bitcoin's blocks are act every 10 minutes. In other currencies, it can be every 2 seconds, every 5 minutes. So that's what people are playing with. And the problem of the size of blocks is represented on this graph. Initially, there were no transactions because the system wasn't well known. Nobody had heard about it very much. But as time has gone by, people now do want to do Bitcoin transactions, and we've reached a point in which the size of the block is full up. This is interesting because it's got statistics in it. And you can see how in July 2016, January 2017, around 90 to 95% of the block was filled. It's what we said previously, so the commissions get higher. Let's look at commissions. And let's do another game. Let's play another game. What we need now are at least 3 people. 3 people. There's a prize for this as well. And not only that, it'll be a prize on a wallet on your mobile. This exercise that we told you about, that we put an address with some money and we tried to get it to be robbed by third parties. We tried to represent it here. This is the QR code, which represents an address where we've put some money. Don't please show the slide yet, because you'll have another QR code, which will be the private password. This is what you're going to have to do. The exercise it consists of, we're going to install an app in your mobile. Those people that come up here, we'll do the exercise together. If somebody's got a different model, that's fine. You don't have to install this. And what you're going to have to do is read this private password, import it, and then generate another address and transfer the money that appears in this address that we've put up there onto your personal address. It sounds easy, but we're going to do it with you so that you can see it as you come up. I'll try to convince some people to come out. Come on, we need 3 more people.
Pueden ser los de antes, que los de antes ya estáis participativos. Venga, los de antes por lo menos, no nos dejen mal. Venga, vamos. Venga, vamos. Venga, dos. Hay alguno que va a ir a casa, vamos, se va a pagar la cena y vamos. Si quieres hay alguno más, le dejamos aquí. Y el resto, los que estéis ahí, vamos, en el público, pues también vais a poder.
The rest of the people in the audience are also going to take part as well. So, let's just hope nobody calls at this moment. We should be able to see what you can see, Yaitha. What we're going to do is, Yaitha's going to do it. If you don't know how to install a wallet, now's the time to do it. Go to Play Store. Those of you that got an iPhone, it's easy. Let's install it. Let's install it. There are other wallets. You don't have to use this wallet, but this is one. Let's install. It's an open source software, Electro installation, and we're going to open it. And the first thing that we're going to do is, let's wait until they've got it as well. It's a different app for iPhone. Jax, J-A-X-X. It's a wallet. Electrum is only for Bitcoin, but Jax is another wallet for other currencies. J-A-X-X. Anybody else got there? A couple of people have raised their hands. Maybe to import the private password, you're going to have to skip this bit. I said to you earlier that if you've got a Bitcoin client, normally what you do is download the whole of the block. But you don't have to do that now. Since the more recent version, you can just download the 2 final gigas of the block. Or you can use light models. And you can use Jax or Bitfinex and consult the information because, for example, in your mobile you may not have enough memory. This is the way which systems have of making it more user-friendly. So the first thing we're going to do is generate a standard wallet. It's going to be your personal address. And you're going to see Yaitha's on the screen.
Aquí tienes otra aplicación, pues mira, aquí tú puedes elegir Bitcoin, Ethereum, etcétera. Pon solo Bitcoin, ¿vale? Pon solo Bitcoin, ¿vale? Y ahí, take me to the wallet, to my wallet.
Vale,
Son parecidas
creamos...
todas.
Vale,
En este caso, en la de Electrum, pues lo que vamos a hacer, Yaiza va a generar...
And Yaith is now going to create a new wallet
a partir de una...
using a seed.
¿Vale?
Vamos a dar estándar.
So we
Pinchamos en estándar.
click on standard,
Fijaros,
and this is how this works.
para evitar que os pase lo que le pasó a uno,
Devoid
¿sabéis? Vale.
happening what happened before,
En base a
you
una
just
serie
have a
de
wallet using a series of words,
¿vale? En base a una serie de palabras.
Cancel.
¿Vale? Que son moral, okay, man,
and there you can
valid,
see
fine,
all the
scatter,
words
peace,
up there.
color, racing, peace, approach.
These
Estas palabras
words,
nosotros las tenemos que
we have to
copiar,
copy them and
guardadas
save
en
them
algún sitio,
somewhere, because if
porque
we
si las perdemos,
lose them,
si, por ejemplo,
if
el
the
móvil se
mobile,
pone
we drop it down the toilet,
vas a una
or
locomotora,
if
por ejemplo,
a train runs it over, or if it just breaks,
pues si no
if
tienes
we don't have
esas
those
clavecitas,
keys, these words, we're not going to be able to recover the bitcoins that we've got in the wallet.
¿vale? Dale a next. Dale a next, le damos a next.
Sí.
Ya las tienes, por ejemplo. Dale a back. Las escribimos.
So we'll write them down.
Venga, a ver, cada uno del público que almacene una.
No, espera, que las apunto
A
aquí.
ver. Report.
Espera un segundito, a ver si las puedo...
Sí, lo que pasa es que voy a tener que estar cambiando de
segundo,
tal.
un segundo.
Trae, da igual. Da igual. Report. Flight. Gorilla. Huge. Kids. Wine memory. Venga, next.
Tú también tienes, venga, apuntamos las tuyas, lo que pasa es que luego ten en cuenta que Coordina las está viendo, o sea que luego Coordina las ¿cómo lo hacemos?
Con una foto.
Ah, perfecto, sí, mejor. Venga, yo voy metiendo las siguientes, ¿vale? Venga. Ay, next. No. Oh, espera, Félix, ¿eh? Que le he dado. La he liado. Félix, la he liado porque le daba back. La he liado. Venga, labor. Sí, es que cuando das a back se te vuelven a... Trip, slash, tomorrow,
Slide, fantasy, account, with, think, bright, circle. ¿Vale? Le damos a siguiente y ahora Yaiza la va a copiar. De hecho, te ayuda ya la aplicación. En este caso, Electrum lo hace así, pues para forzar, obligarte
Here what we're doing is forcing you.
a que tus claves tengas una copia.
In the case of Jax,
No hace...
it's not so difficult. You done
¿Ya lo
it?
habéis hecho? Ya, aquí tenemos la gente que ha utilizado Jax, la aplicación es JAX.
Those of you that want to use Jax, it's JAXX. In this case, we've been forced to use this different one. Different approaches. Here,
¿Veis aquí de todas formas? Pues bueno, vamos a... estamos
this
tardando
is
un poquito,
taking a
pero bueno,
while.
esto se supone que es para hacerlo más seguro. Espero que luego no... Vamos, no, tú no participes, que te lo va a llevar alguien que esté en esto. Vale. Y lo que vamos a hacer es... Vamos a generar
With this
por esta
seed,
semilla, pues,
every
cada vez
time
que
we
tenemos una nueva
need a
clave,
new
pues,
password,
a partir de
it's going to be
todas las palabras que
generated
están
using all those words that are up there.
Fantasy, account, valid, with, think, bright y zero. De hecho, esto es para que tengamos, en lugar de vosotros importar
It's
directamente
so
las
that
claves
instead of you just
que os vamos a enseñar, para que
importing
tengáis vosotros otro
these
modelo,
passwords, there's another way you can do it. That's why we're doing it like this.
bright y zero. Ok. Ahora va a decir
Now
que
you're going to be
efectivamente
told, yes, it
coincide.
coincides.
Next.
So
Y nos va
next,
a
and
pedir
it'll ask you for a PIN number, yeah.
Vale, os pido un pin.
So create yourself a PIN number.
Que estamos en las mismas. ¿Vale? ¿Tenemos a Yaiza? El pin Yaiza también nos lo
Yaiza's
dice para que
making
todos sepamos.
it difficult
En este caso,
for the PIN. So remember your PIN. otherwise we're going to have the same problem.
Vale.
And now the passwords are being generated.
Una buena agencia tiene 0 milibitcoin, ¿vale? Por ejemplo,
If
si
we want to,
quisiéramos enviarle, Yaiza quisiera cobrar
if Yaiza
ahora,
wants
esta botella, pues
to
le dice,
charge
bueno,
us
doy
for
esta
this
botella
bottle,
si me transferís
she can say to us, okay,
a
I'll give you this bottle if you transfer to this address 1 Bitcoin.
Bitcoin no, Bitcoin sería una botella,
It's a cheap bottle.
¿vale? Pero nos daría esto. Entonces, tendríamos que anotar esa
So we'd have to write
dirección
down
una
this
persona para
address
poder transferir. Con esto nosotros
and then
ya tenemos
transfer. So
un conjunto de
here we've got a whole
direcciones.
set of
Los que
addresses.
lo tengáis en
And
Jax,
those of you got the Jax app will see it differently. So what we're going to do now,
os vamos a
we're going to
enseñar lo
show
que
you
también en el streaming. Vamos a enseñar
on the
ahora aquí a la
right
derecha la clave privada asociada a
the
esa dirección de Bitcoin.
secret or private key associated to this Bitcoin address. So you have to scan the QR code to import it. There's probably a part in the app which says import private keys. I'm trying to do it as well.
Transfer paper wallet. Ah, es que pues en Jax no lo podéis hacer. Claro, la tendréis que copiar ahora. Ah, pues también puede ser, otra opción. Vamos a mirarlo ahora, ¿vale? Enseñamos cómo lo tienen que hacer, ¿vale? Para la importación.
Voy a salir de la toma.
Y os vamos a enseñar, volvemos a otra.
So okay, we're going to go back and you can see where we are. I'm going to show you now how to import a QR code.
No se ve bien, ¿eh?
¿No se ve? ¿Por qué? ¿Se ha ido? Sí. Voy. Venga.
Directo aquí. Vale, entonces yo ahora la misma dirección.
Espera. Tengo que... Venga, ya está. ¿Ya estás? No me sale todavía. Venga, aceptar.
Y yo le doy a screenshot.
Iniciar ahora.
Eso es.
Venga.
Vale, ya lo tenemos. Venga, lo enseñamos otra vez.
Okay, let's repeat and show you how to do it again. We'll open Electrum and you'll see all wallets are similar to this. It's just to import keys that are written in a QR code. There you can see the 3 bullet points and wallet. And there we go. We click on the new wallet. Here we're going to give the wallet a name. CyberCamp in this case. And here you can see import Bitcoin address or private key. You have to write it in.
Aquí yo ya me voy, ¿vale? Y vete a la presentación.
And let's go back to the presentation now. So, what we're going to do now,
Ahora le tendríamos que dar ahí. Y ahí
and there you go, you can see the private key. Anybody in the public, if you can import it before, you should be able to. You got it? Anybody that's looking at this, the quickest of the quick can get the money that's associated with this private key and take it into their wallet. The quickest one will be able to have control over the money. And as we're sharing this with many people, there can be many people who are simultaneously taking the money. In theory, you should have a QR reader app. That's another option. They're all just different examples. What we want you to see with this is that anybody now could be taking the money that's in this address. We'll give them 5 more seconds. And let's see if there's any transaction in blockchain.info. And let's see if somebody's stolen it. There you go. It's the person here that did the transfer. Look at your address. Is that you?
Pues por asociación.
Pues puede ser tú, pues puede
It
ser.
may well be you.
Vale, pues aquí
mira a ver
tenemos
si-
una persona, fijaros que pone confirmación, o sea, transacción unconfirmed, no confirmada.
That is,
Que alguien ha hecho
we've got
la
the
transacción, pero todavía no se ha añadido a la cadena de bloques. Blockchain
transactions
no sabe que hay
unconfirmed,
una-
but it hasn't been added to the blockchain.
Mira a ver si tú eres el
Do you have
de
that
la
address?
dirección
Is that your address?
18?
18.
Vale,
It may well be
puede ser,
that
puede
it's
ser.
you.
Vale, de hecho, fijaros,
Here,
aquí habíamos transferido
we transferred 0.001, and it's ended up in 0.0065. So almost 30%'s gone in the commission.
Con este ejercicio,
So what we're trying to show you with this is
para seguir con la... Para seguir, lo miramos, que
Sí,
si no nos come
vamos a
tiempo,
seguir.
¿vale?
to carry on with the
El ejercicio
exercise.
lo tenemos hecho, ¿vale?
What
De
we've
forma
done
simultánea,
is
de hecho, puede ser que
simultaneously,
en este tiempo haya otra persona
and it
que
may well be
efectúe
that
también
somebody
otra
else
transacción,
has
que haya dos
carried out
transacciones
2 or 3 transactions of the same money and they're trying to move the money all at the same time.
Vale, entonces,
Let's
vamos a
now
regresar
Let's go
a
back to
esta
this
slide,
slide.
¿vale? Donde
We
decíamos que
said
ya
that
el
the
tamaño
size of the
de la cadena
blockchain
bloques, o sea,
and
el
of the
tamaño de los
blocks
bloques ya estaba
was
rebosando.
too much. So the
Entonces ya la comunidad
community,
dice,
Bitcoin
pues, bueno, ¿qué
community
hacemos?
says,
¿Qué
what
hacemos?
can we
Van a
do?
ofrecer, si
If we
estamos pagando
are
comisiones de $5,
paying
pues a lo
commissions of
mejor deja de ser
$5, this
competitivo
is
porque
not
las empresas, la gente se
competitive,
va a
and people are
otras
going to use other
criptodivisas. Tiene que saber,
cryptocurrencies. So we
vamos
have
a
to take a
poner esto, ¿no?
decision.
Y de ahí es
And
donde pues
all
iban
the
todos los
forks
forks
that
que
are we
estamos
seeing
viendo
here
ahora
from
del
this Bitcoin
de Bitcoin.
project
Pero
emerge.
hay que
So in these
diferenciar entre
systems, we have
los
the
hard
hard
forks
forks
y
and the
los soft
soft
forks.
forks.
Los
Hard
hard forks
forks,
son
what
hard forks
are they?
un
A
cambio
change of the
en el
initial
protocolo.
protocol. There's a
Es decir, hay
change
un cambio
in
en el
which
que hay un cambio
in the
en el
Bitcoin
protocolo.
protocol.
¿Vale?
Until now,
ahora, por ejemplo, desde el
since
año
2009
2009,
to 2017, the
la
Bitcoin
comunidad de Bitcoin se ha regido
community
por
has had
clases
rules by
establecidos
consensus,
aceptadas
socially accepted
popularmente
by
por
all.
todos, etcétera, etcétera. Entonces,
So from the
desde
first
el
hop
primer nodo hasta el momento,
to end
hasta
block,
el bloque N, desde el bloque 1
from
hasta el
1
bloque
to
N,
n, they
han seguido
follow
bajando
the same rules,
1
1
mega
mega
el tamaño del bloque.
for a
Sin
block.
embargo, por lo que está diciendo
But
Yair,
then
hay
there
una
are the
serie de
people in the
personas
community
que son
saying with
asociantes
1
y consideran
mega, they
que está
pay
bajando sobre
$8
bloque.
commission. That's a lot.
Eso es una burrada.
We have to
Hay que ampliar eso.
enlarge the
Ampliar el
size of the
tamaño del
block
bloque
from 1
de 1
mega
mega a
to
8 megas para
8
que más
megas for
transacciones
more
puedan
transactions and
realizarse.
lower
La gráfica es
prices.
inverso de lo que hemos estado viendo del programa que hemos visto.
So the
Entonces, el sistema
Bitcoin
de Bitcoin al
system
final
is in
surge
parallel.
en
So
paralelo
we have
el
Bitcoin Cash
Bitcoin Cash, que es el que
with
tiene
a
tamaño de
size
bloque a 8
of
megas.
8
Eso es, hay
mega.
gente que decide
People decide to
mantener
keep the
la
philosophy
filosofía
of 1
de un
mega
solo
per
mega por
block,
bloque máximo
following the
y entonces
original
lo mejor
protocol.
y lo que sigue, que en este
That's
caso
what
como
most
era
people do.
lo que sigue
So the
sería la
Bitcoin
parte de
part,
Bitcoin, lo hemos escenificado
it's in
con la
yellow.
color amarillo, ¿vale?
This is a
Una cadena
blockchain.
de
And
bloques
another one,
y otra que
these
es
people decide to
ampliar
enlarge
el tamaño
the
del bloque a 8 megas.
block
¿Vale?
size
Esto da lugar a
to
otra
8
cadena de
megas.
bloques
So it's
diferente.
another
Estamos
blockchain.
en verde.
Luego también pues
So
surge a
from
partir de la
the new
nueva cadena de bloques
blockchain, there's other
otros proyectos
projects
también
emerging,
como
like Bitcoin Gold.
Bitcoin Gold.
But what
Pero ¿qué pasa?
happens? There's
Fijaros,
another
hay 8
change
cambios
in
de
the
las
rules.
reglas.
The community
Existe la
says
posibilidad
one
de
part
una
of the
persona que
Bitcoin
tiene
community
Bitcoin y
says
dice, oye, es que
the problem is that
el problema
control
es
is
que
in the
los
hands of
proyectos están en
miners. They are in
China,
China,
no sé dónde,
all over the place, in many
un
places.
montón de sitios.
They have a power,
Tienen un poder
and it's
que
not
no es
democratic,
democrático, porque
because those who have
tienen
more
más capacidad de
computational
locura para
capacity
decidir
say what
transacciones.
are the
Y van a
transactions to
tener
be
un poder
inserted.
sobre
They have a
algoritmos.
power over economy.
Entonces,
People say, I'm going to invent my own algorithm to go back to
el propio algoritmo
the
propone
philosophy, the
las
original
políticas exactas. Si votamos,
philosophy of
en
Sakamoto,
cambio
and
será una persona,
it's one person, one vote.
voto máximo.
And Bitcoin Gold has been created.
Fijaros,
In this case,
en este caso pues sería, por ejemplo, lo hemos escrito como
it's the blue chain.
cadena azul, en este caso.
Lo que
In
habría
this
que hacer en
case,
este caso es
those
que
who have
aquellos que tengan
Bitcoins
bitcoins, ¿vale?
can,
Podrán
that were bought here on the left,
comprados ahí en ese
they
tiempo,
have
tienen bitcoins de
the
los de
Bitcoins
arriba,
up on top, they have
tienen
Bitcoin Cash, and they have
tienen
one Bitcoin Gold.
Es decir,
The
los
Bitcoins that
bitcoins que
we've
hemos visto,
seen
por ejemplo,
in
de
the
la
wallet I
persona que
had
cotizó
in
del año 2002 a
2012,
69 céntimos de bitcoin, sería, por ejemplo,
N
en
minus
ese
2,
momento,
that was
¿vale?
the time
Cuando estaba la
with the
cadena de bloques
original
original. Esos bitcoins de
blockchain.
N-2 se
You
podría
can
extraer de la
spend
cadena de
it
bloques
in the
y
general
generar
Bitcoin chain,
la de Bitcoin, se pueden
you
gastar
can spend it on the yellow,
con colores.
you can spend it in the green ones as Bitcoin Cash, and you can spend it in the blue as Bitcoin Gold. In fact, I have 3 ways of spending the same Bitcoins. But
Pero
it doesn't mean
eso no
that
quiere decir
people
que los que
having
tengan
Bitcoin
Bitcoin
Cash
Cash tengan
have at the same time Bitcoin Gold. If I'm paid in Bitcoin Cash here and plus 4, I'll come after the fork. I can't spend it in normal Bitcoins anymore. I'm in this chain only. In some situations, when we assess the value of a Bitcoin wallet in 2014, that was before the fork. But if you have several chains, you have different types of Bitcoins. You can earn a lot of money. The other soft forks,
al final no es un cambio
the other ones were hard forks. These are new functionalities that are added to this system. As an example of soft forks are the multi-signature wallets, a functionality that was created in 2013, in which you need at least some people belonging to this wallet to move your money out. It's a soft fork because it's a change in the functionality of this currency, but it's a change that is compatible with the hubs backwards. Blockchains are not totally different. In the previous case, if one hub generates a block of 3 megas, in the Bitcoin blockchain, it's going to be accepted because it's too much. It's more than 1 mega. These are soft forks, new functionalities. New functionalities in this case. Multi-signature addresses didn't exist in the concept of the original concept by Nakamoto. It came later on. And there is a map of currencies called Web's Macro Coins that is not being updated, but it's quite interesting. Here we see, since 2008, these are the different implementations. We can see it from the beginning. There's an explanation of what this is. The first fork is NMC, Namecoin. Here you see subdivisions, new implementations of the original source code. Instead of 10 megas or 10 minutes, it's every 5 minutes. Or instead of using an algorithm for proof of work, they use another algorithm. That's happening with Lipcoin. And the tree is growing. And the tree is growing and grows more and more. So after these implementations, there's a nuance to each implementation. 1,177, so a lot of them with these forks. This is another website. If you really like this, you want to monitor the price of each currency and how much it costs in comparison with other currencies, you can use this website to compare the currencies rates. So now it's going up. The price is going up after our talk. An hour ago, it was less than that. And here we see 100. View all here. View all. Some of them have strange names. I don't want to point at anyone because maybe you are the authors, but you go down and down. How many are they? How many? 1,318. These are not all of them. We can have projects with more than this. Tattoo coin, that's another one. What is the philosophy of tattoo coin? I wonder. It's a reference point. So we've spoken about the mining costs. It's not very cost effective. It's not very profitable to mine anymore for us. In 2012, in a PC, it could generate, well, a PC like mine could generate 20 million hash per second. It's millions and millions that you need. It was a very small part of the computational capacity of the network. Now it's growing. Now has been divided by 600,000. It's a tera or something. Figures are so big, sizes are so big, so we normally the mining was done with graphic cards, but now you have ad hoc chips. We have experts that solve the mathematical problems in the whole world. So the energy consumption is brutal. It's huge. So these are statistics that were published recently. There were countries that spent less energy than the energy needed for the Bitcoin network. 159 regions or countries in the world, 159 countries that consume less energy annually than Bitcoin energy needs for mining. Small countries. Well, that's an anecdote, but two other cases are quite significant. So what would you do? What about a malicious agent? They don't want to spend their energy. So instead, I will develop malware so that others mine instead of me on my behalf. This is started 3 years ago with this malware. So malware are in fact using you to mine, and you're mining on behalf of them. No, it's not only stealing credentials, bank accounts, and pictures. Now they steal the capacity for your computational capacity. This is a report. It was a checkpoint report on the 13th of November. So the sixth family of malware in the month used to mine or to ask you to mine on behalf of them. So the sixth malware family, the most prolific family of malware, was related to mining. This is the checkpoint report. How to mine, how to finance. You can use a small software with .exe to mine in your computer. Well, instead of looking at ads, you can see JavaScript that's uploaded underneath. CoinHive or cryptoloot.com, they offer a small library. We can click on it, 30% commission out of the computational capacity that you generate with your browser. 30% commission goes to CoinHive. It's stipulated in the project. Let's have a look at it. So, JavaScript miner. Do you trust it? This is a JavaScript code that is embedded in websites with hive.mim. I'm not an expert in JavaScript. Miner prototype, JSON parse, you can read it. Something is happening there. Let's have a look at the next one. It's 12% commission in CryptoLoot. Do you trust this code? This is malware. Let's see if it crashes again. Okay. Do you trust this? Maybe it's optimized. I'm sure of that. This is optimized for efficient mining, but I can't really see it. I can't debug it, really. It's more complex. These CryptoLoot and CoinHive are projects that you can see it. They have their own business model. This is used in websites with the underneath JavaScript. You can use Pirate Bay or any websites of this type. While it was open, it was mining underneath or behind it.
Esto está siendo bastante extendido.
This is extended, and we have these add-ons, browser add-ons. So these are the websites that you're browsing, and it's identifying if there's a code. So HTTPS, blockchain, you have all these signs appearing, all these threats that we're having. This is no coin. You look in Chrome Store or in Firefox, you have this project also in GitHub. You see all the pages that are being blocked. No coin. What was the first transaction in the real world in Bitcoin system? It was the famous pizza. You know the case. In May 2010, a user of a forum, well, you may have an address, an account. This was a Bitcoin forum. Laszlo was the name of the user. He set a challenge saying, if you bring me 2 pizza now to my home, I'm going to offer you 10,000 Bitcoins. And he put the photos of the pizza. So somebody sent him the pizza. And now, well, on the 22nd of May, when this transaction was made, it's the Bitcoin Pizza Day. And there's a Twitter account that is monitoring the price in dollars of what this pizza would cost now. It's 97 million per pizza. So it's $96 million now. That's the value of that. This is an anecdote. It was originally used as a payment system in order to avoid the central control of banks. We can use URLs here so that you know them. Localbitcoins.com. It's a site where people who want to buy and sell Bitcoins can meet physically and transfer those Bitcoins. But the platform here will charge us a commission for having these two people meeting really. And then coinmap.org here, coinmap. We haven't looked at this here in Santander, but there's one in Madrid. If you want to buy, you can choose Spain, online offers. I can't see it. Here. Here. In-person cash. Let's see, do the search in Spain to see what we can do in Spain. Not many of them. Here. In Madrid, another one in Valencia, Alicante, Denia, Benidorm. Here, different profiles, different people. They want to buy Bitcoins. They want to buy Bitcoins. Or they want to sell Bitcoins. They meet in person and they can do the transfers. They can exchange 10 Bitcoins or $10, and they can exchange their currencies. Another website, coinmap.org. Coinmap. On this website, it's a project where different bodies upload the fact that they are Bitcoin friendly. They do accept Bitcoins or other cryptocurrencies. Let's see the map. Who accepts Bitcoins? See if there's something in Santander. There's several shops in Madrid. Some here, a couple of dots. I don't know if we can show them or not. In some of these dots, they say they do accept Bitcoins. In Madrid, there are quite a number, especially in the center of the city. It depends on the adoption level. Then you can see where you can spend your Bitcoins in physical shops, in stores. So this is CoinMap and local Bitcoins. A bit type, well, it's kind of different type of platforms.
Pero
As you
utilizáis
may know, this can be used in the blockchain to transfer money
¿vale? Como puede ser por el tema
with the
de
Bitcoin system, but sometimes it's interesting to include information. For this,
para ello.
a
Una
transaction
transacción se vería
is
tal
shown
que
like
así,
this,
¿vale?
is viewed like this.
Pero
But
desde
in
2013
2013, there's a new
una nueva
functionality.
funcionalidad
You
que se puede
can
meter información en un
use
código que se llama
operator,
OPE.
that's the code.
En ese código que
In
se llama OPE,
OpenReturn, you can
pues
put
meter
80
claro,
bytes of information.
aquí el
Here,
ejemplo que ponemos es
it's
el
an
típico
example,
ejemplo que
very
hemos
typical.
tenido de Charlie Los
Charlie
Heidi
Los Haiti.
y bueno, que sería
It's
esa
Está
been
almacenando en la
the
información que se incrusta en la cadena de
instead
bloques,
of
en lugar de
storing or
meterlo
saving a transfer, you can
si podemos
add an
pensaría
exit.
que en lugar de
Instead
hacer
of
30 bytes,
making
sean
this
40, 80
monetary
bytes.
exchange, you can put 30 bytes. That was before 2013, but it was made official with Open Return with 80 bytes that you can use in the blockchain.
Como vamos a ver ahora.
vale,
So
una de las plataformas
Para que
que
se
this
pueda
is to
para
estaría
include
entrar en
information
con las garantías, o sea, apoyándonos en
because we
de
take
la cadena
advantage
de bloques de
of the
Bitcoin. La cadena de
Bitcoin
bloques de Bitcoin está
blockchain. It's
distribuida en un
distributed
montón de
on
red
many
nodes
internet nodes that keep
que
a
guardan
copy,
una copia.
that save a copy.
Nos aseguramos que
So
esos contenidos fuentes
if
guardan
we
esa
can
copia y podemos
embed
necesitar
some
alguna
information, some
información.
data,
Alguna
but
información
people are
más. A ver cómo lo podemos hacer.
thinking
Ahora lo vamos a ver.
evil,
También es
but
bien
also it's for good and for bad
también
at the same time.
vale,
This
la plataforma podéis
in this platform, we can see in
todas las
real
cosas que
time
se están emitiendo con información
the
en ese
information in
cacho que se
the
llama
Open Return.
Bueno, pues aquí vemos
This is Omnition. It's a protocol
un protocolo que
that
está implementa una nueva
implements a new
funcionalidad
functionality
apoyándose
with
en
OP
esos 3
Return,
de Bitcoin
Open
pues
Return
para
to save
guardar
and
cierta
store
información. Aquí
some
lo vemos como un
specific
gigabyte.
information.
Lo vemos como un gigabyte,
These
pero en
these
realidad
are
son datos,
data,
¿vale?
what
Lo que
they are
están
sending.
enviando. Lo vemos como un interrogante porque no tienen igual sentido la visualización.
Most
la
of the
mayoría de trades
projects
y que ahora
that
lo que
you're
estáis viendo
seeing
que
in the
los datos
media
que están saliendo
for
en
blockchain,
blockchain,
in
la mayoría de esos
most
están utilizando
are using OP return
para, pues, para
for the
información
timestamp
de lo que
of the
fuera, de documentación
documents
de
or
documentos o de, oye, de una marca
signing time.
financiera o
Apoyándonos en que va a
We
estar
know that it's going to be there
Bitcoin
because this protocol is being developed
para perdurar, ¿no?
to stay.
La red
So it's very difficult to find a single failure failure point. But now you have a guarantee. Not only it's there, you can have it in other social media, but it's there, and what is there is going to be there in the future, as long as Bitcoin exists
lo que comentábamos
in the
de
new
funciones que están
projects.
saliendo,
For
como el tema
instance,
de registro notarial,
notary
que lo habéis
registration.
escuchado. Pues
This
este
project is
proyecto
quite
sería una cosa
similar.
parecida. Se llama
Proof of existence, the URL, it's there. You only need to put a document there. We type it, and then a hash is associated to that document. It's the identification number of that document. This hash would be embedded in the OP return field, and this is kept there. So you have a book, and this is my book. I can generate a hash of this document, of this book. It enters the blockchain. I can always say that this is mine. I can use it and say this is in the blockchain since the 30th of November 2017 at 7:30, and it's mine. There's the registration is there. If one bit is modified, the next blocks would have been different, but at least you can anchor that information and guarantee it. It's proof of existence. So this could be used for bad. So before the command and control, and the tools that malware uses to be in contact between the victims and the administrator, where the infected nodes that belong to a network, once it's centralized, the victims have no communication on this system. With our IRC chats, it was the same in 2008, etc. Well, in IRC chats, maybe it's not that common in web servers, and now this is happening in social media. But the specificity of social media is that that will always be there. This case was quite well known in the social media. The malware author used the command and control in Instagram. See, if they find it in Instagram, everything disappears. So if Instagram crashes, and this is the Britney Spears profile, if Instagram crashes, it's the end. So Instagram is not going to crash. So I'm going to put comments on the photos given by Britney Spears, and I'm going to send with a strange method, which is quite difficult to understand. I'm going to send the information to which the victims have to connect to find command and control. So it wasn't the URL there. It's a little system with a comment. It takes the first character of each word, and it generated the bit.ly address, the Britney Spears address. Why? Because he wanted to find a site that was very, very solid and that couldn't crash. So we've seen it in command and control, but also for social advertising of the ISIS, Islamic State, EI, and we found an extension that was distributing this ISIS propaganda to all the people that could be radicalized. And so they installed the application, and at all moment they knew what were the website sites they had to consult to consume that information. The author of the propaganda could manage the content of the propaganda, and there was a server that was pointing to the websites where the propaganda should be present. So if, next one. So if the propaganda website crashed and they had to get a new website, there was an automatic notification. The user is transparent. The add-on was installed already. The add-on was there. We can see it now. The add-on had this code, very stupid code. It doesn't work in Firefox Quantum anymore. So on this server, that was the number. Well, it's not available anymore, but it was updating the new address on which the radicalized content was present. So there was an updating of the websites that you could see for radicalized propaganda. So you can update it automatically with this. But if somebody identifies that your users seeing this content are using this add-on, instead of throwing away the destination pages, you can throw away the central failure point. And the problem for propaganda was the same. They had a single failure point that could be controlled and blocked. So this could be this could be optimized with blockchain, but with a specific goal. In our opinion, we think that in several years we'll see use case of malware samples that are anchoring in this blockchain. Malware is ensuring itself that this content is going to persist and it's going to last. So in the blockchain here, we can use it as a command and control, and the source code is there in GitHub. You have it here. This is the source code. It's quite a simple project. A requirement file, Pepe style. That's all. Here we have the small software for the administrator. Here, from two addresses that are managed by the administrator, we're going to use LaTeSD not to spend any money, and we're not going to use Bitcoins there. So we put the information that we want inside the OP return code, and then the victim's part here. They would go to the code that we have published. They're going to download the transaction list, and here there's another example here. Let's see it with an example. So it's downloaded. You can do it also. It's not just for command and control. You can anchor any content. we think that this is a possibility. We didn't identify this possibility. We've looked for that. Malware samples that try to avoid this behavior. We didn't find any. Maybe they haven't been detected by big security companies, but we think that this is a reality. It might be happening already. So we go to the admin part, admin, and this is a small file. Here it is,
Lo hacemos así primero sin pushear, ¿no? Lo hacemos primero sin pushear.
without pushing.
Una interfaz, pues así. Una interfaz, pues así.
It's very simple
¿Vale? De consola.
with console A. First question, choose the type of network that you want. We can choose Bitcoin, Elitecoin, and the one we use for tests is testnet by Bitcoin. But for this, you don't need money. You don't need real Bitcoins. You want to transfer any information, not the coins. And it has to be there for a certain time, intro, and the brain or other concept. It's mental wallet. We're going to use this mental wallet for a simple operation. In this mental wallet, CyberCamp. So I have an address and the private key. It starts with M. Testnet by Bitcoin starts with M. This is the code that represents the private key. Testnet, yes. 11 Bitcoins in the testnet. It's not real Bitcoins. We don't want to spend that money. And then notepad.exe. Now it's asking me the address that is receiving the money. Notepad.exe, the hexadecimal chain, and what is the address you want to send the money? And then we want to anchor the content there. Break, and then you don't need to have another address. I can resend the money to myself. You don't need to have a new address. I'm generating another address with the same key, the same word, if you want. It's the same that's being generated with a commission. And this is the transaction that is being signed. What is the aspect of this Bitcoin transaction? This is a Bitcoin transaction. We can push it with this command, chainput.soc, that's the centralized service, or we can ask the program to push it alone. So the push option, and this is going to follow the same process. Brain, we choose the keyword CyberCamp. Do you have money? Yes, we have money. Notepad. Target. It's the same. Use the same. CyberCamp. Okay, commission, 10,000 by defect. And that's it. It's pushed. It's been generated. It's here, pushed. Now, it could be a fake. You're showing it to me in the console. Go to coin secret, the testnet, and here it is. Here, it's notified to the network, and this information that we want to anchor is there. Now, there is a Bitcoin address that has notepad.exe that has been anchored. What are we going to do? The inverse process. This is the victim's part. It's implemented in JavaScript because we made a modification of the previous add-on so that it could be used as DNS resolution tool with an add-on, and this is with JavaScript. Okay. So we're going to run it. We're on the testnet. Let's copy the address
This address is the one that was hacked in the malware.
Vale, pues vamos a copiar. Eso es.
So we copy and paste. And if we've done it properly, what it will do is it'll consult the blockchain. Just to check that it works, we've got the notepad, and then what we'll do is try it again to see if we can open the calculator. Let's do it again.
Vale. Pues lo
Vale,
mismo.
esto estaba... No, esto estamos en la víctima.
Admin, ¿no?
Vale.
Vale. Pero es lo mismo.
The advantage is that the content that we've anchored cannot be modified.
Nos sorprende que todavía no existan soluciones.
We're always surprised that these solutions don't exist yet. We'll do it again. In this case, we're pushing CyberCamp. These are bitcoins in the test net, but there are services that you can get the bitcoins to carry out your tests. You don't need to get real bitcoins. Then we're going to transfer it to the same account.
Y ya está. Ahora tenemos que ir otra vez.
Then we have to return to testnet. We may have to wait for a while.
Aquí está.
Esto, porque ha tardado
It takes a while
puede ser que hasta que el
because
que tenga
the hub
llegue la notificación de la nueva transacción.
may take a few seconds to be notified.
La parte de la víctima que harían las víctimas.
Let's go to the victims. You can imagine what's going to happen now.
En este caso, se puede utilizar, por ejemplo, para guardar ahí el command.
Here you can use this, for example, to keep command and control.
Ahora la de arriba.
El proyecto, la verdad es que
Creo que la misma.
vale.
Here's the calculator. That's sufficient for us. But imagine that it was the central server. If the machine doesn't work, we can get another one. We can keep changing it as a mechanism to avoid censorship. And if you're going to be able to access the blockchain, you can use these kinds of platforms. But these kinds of platforms are limited to 80 bytes of information, but there are other options if you combine it with our technology.
La tecnología que hemos
And the technology that's using is IPFS. It's another P2P network.
pero lo que se podría estar haciendo
But what you can do is anchor
de ese IPFS de donde se está almacenando.
where the information is being stored here.
¿Vale? O sea,
Let's imagine we want to anchor all of this content, and there's more than 80 bytes here. It's just an example.
vale, tendríamos ahí
Here we've got a pointer,
eso.
which is all this address. It's not 80 bytes though. And you link to torrents, and with this,
Por ejemplo, con esto, tenemos el puntero al
we put the pointer in the right place. And what we can do is load it from platforms such as ipfs.org.
Puntero
la parte así. Por ejemplo, es una
That's one option.
esto se utiliza, por ejemplo, para
This you can use to keep pictures. If you can't anchor the picture in the blockchain, you can have a pointer.
Vemos también que esta
And this technology has been recently
en el referéndum del 1 de octubre
used in the 1st of October referendum in Catalonia. It was used to avoid censorship. Here they were blocking access to certain websites of the government, and so what they did was link it to other these kinds of places. These things exist, and we need to know that they're within everybody's reach. And it's a solution that's traceable. Other great things are Namecoin. This was the first fork of Bitcoin. It now can store 520 information bytes. And there's an add-on, a browser add-on. Namecoin, Namechain info is like Bitcoin info, but it's just with Namechain. Our personal domain is .com, but here we can, in the blockchain here of Namecoin stored in this structure for IPs, if I say to you, and you see, oh, this is a .bit, and it may be something in Namecoin, and you can see the information that you, and the IP address that you need to connect to get the information. It's just in a different format. You could have the whole blockchains of Namecoin there. Another interesting project is Ethereum. Ethereum is another platform, but it's also a crypto currency. And what makes it different to Bitcoin is that you can de-anchor certain smart contracts, little programs that you can say, oh, run when this option is chosen, or do this when it's finished. Instead of storing information, they're little programs. If they're programs, you can sometimes validate them incorrectly. In this year in DEF CON, there was a talk just on this, about security in Ethereum. There have been at least 2 cases of smart contracts which gone completely wrong. And just to show you a little bit about the technology, with the Madrid-Barca match last year, we did a smart contract. We usually do pool and do lotos. Instead of physically having to put €2, you had to put €2, real euros, and 1 in Ethereums. So it was like the normal collect round, whip round. And that was our way of giving people the opportunity to take part. So they put the results in there. Once the match had finished, you could pay people out. And then we forecast the user could say to the contract, I think it's going to be 0-0 or 3-3. So when the game finished, the administrator was the person that had signed the contract, said, okay, the result was 3-3. And then you pay the winner. Automatically, what the code does is it check whether results had been typed in and whether the person that typed in was the organizer, administrator. Because if you didn't do this check, anybody could have run the contract. So we divided it up. we tried to see who'd won. If there'd been 2 winners, we divided it between 2, the 3, 3. So another interesting thing would have been automatically to consult the web. And there are projects now with airlines that are trying to use smart contracts. For example, if the flight comes in late, you can automatically return the money that the user actually has paid for their flight. There are lots of use cases. And with blockchain, it's all related to supply chains. Imagine what we manufacture cars, and each part of the car goes through a different process. And for example, I get a part and it's perfectly fine. The aim is, if you get a part that has got a defect in it, you can find out where the chains failed, so as to be able to find out whether something belongs to you or not. That's digital property ownership. Proof of existence, you anchor a hash to a document. But if you've got to anchor 1,000 documents, then it's different. They're all very powerful, and just anchoring one hashtag, you can guarantee that a document you don't need 1,000 transactions. There are startups that just do that. Then smart contracts that we mentioned before, and provide security to digital identity and the Internet of Things. And to finish, the ICOs, initial coin offerings. Have you ever heard of them? ICOs is a new way of funding that many organizers have found. What they do, they have tokens distributed amongst those who were originally in the project, and they get economic advantage. So if the project is a good one and it is attractive, these people that invested at the start get a profit. Imagine that instead of using this kind of project, we want to fund people with wiki starters and Goteo here. You can do it without need of having an intermediary. Some countries are concerned about this. In China, they're very, very concerned, because here there's not so many means of controlling that actually what they say they're going to do, they actually do, and how people are managing the money. If in the real world you have problems, imagine if you remove all the security measures and you get into the digital world. So you have to be careful. You have to be very careful, tiptoe around things. And let's go back to the metaphor that we started the talk with, which is Schrödinger's cat. In this experiment, if you're outside the bunker, the cat may be alive and it may be dead. What you have to take away from this talk is that sometimes you can try out all different solutions such as blockchain, etc. Now they're using blockchain for everything, but it doesn't have to be used for everything. That's why what I mean is that the cat doesn't have to be alive and dead at the same time. You don't always have to use blockchain, because if your project has the characteristics that require blockchain, if they're persistent because the information is replicated in all the network's hubs, traceability, you know where your product is at a given moment in time. Information has a tremendous integrity. You can't go back and change any of the bytes, and that you do away with intermediaries. What you're doing, for example, with smart contracts is trying to do away with any kind of intermediaries. And if you don't have these characteristics, probably blockchain isn't what you need. That's the conclusion we're trying to draw from this. We're not saying blockchain should be used just for the sake of it, but rather blockchain because one of the requirements that are up there are met. We remember in a meeting, people started saying, oh, if you can't tell me why I shouldn't use a CSV for this project, maybe blockchain isn't the solution. Maybe we're making our lives too complicated. Okay? I hope you enjoyed the presentation. I hope you've understood a little bit more about the world of Bitcoin and blockchain. But if you have any questions, here we are to answer them. Thank you. Thank you.